This video is about finding the domain and writing it in interval notation. Again, I have some 10 through 17 there, and then I have some trickier domain problems down below, which I'll do in another video. But just for the sake of this, let's do number 10. All right, so number 10, and again, I'm using like a Word document, which doesn't have fancy equation editing power. So I'm going to rewrite it just to make sure everyone has it or knows what this means here. So f of x equals 7, all divided by radical 2x minus 5. All right, so first of all, I need to recognize that this is a rational function. And if it's a rational function, which means just a big fraction, as kids we were always taught we can't have this number in the denominator. We can't have a 0. Now in this case, we can't have the denominator equal 0, meaning if I plug in a number for x, I can't have the answer be 0. Okay? So that's rule number 1. Now rule number 2, notice how the denominator is in a radical, which is something you've learned as you've progressed in your math careers. We can't have any negatives under the radical because that becomes imaginary. And remember, domain, we only talk about what the real numbers are. So in this domain, there's actually 2 restrictions we need to look at. My domain cannot be 0, and my domain cannot be less than 0, meaning it can't be negative and it can only be positive. So the way I'm going to write this is square root of 2x minus 5 must be greater than 0, right? So it can't be less than 0, and it can't be equal to 0, so it has to be greater than 0. Okay? So to solve this, we would square both sides. So 2x minus 5 is greater than 0. Add 5. 2x is greater than 5. Divide by 2. X must be greater than 5 halves. So for my domain, it has to be greater than 5 halves, meaning 5 halves is the smallest it can be. All right, now I already did a video on interval notation, so check out one of my other videos if you need to see that. But, so the smallest it can be is 5 halves, meaning it can go bigger than that, so I'm going to take it up all the way to positive infinity. We could never include infinity, and it has to be greater than 5 halves, meaning I had to put a parenthesis around 5 halves as well. So that would be my interval for number 10 there. So from 5 halves to positive infinity, non-inclusive of 5 halves. All right. Let's go ahead and take a look at number 11 in this example here. Just for the sake of it, I'll go ahead and erase everything. Just be a little quicker. All right. So number 11... Again, let's rewrite the problem to make sure we all understand it. F of x equals radical 1 minus x over 9x cubed minus 16x to the 4th. Okay? All right, so it's again a rational function, meaning it's a fraction. What can I not have in the denominator of my fraction? Any zeros. So the denominator cannot equal 0. Okay? So let's just go ahead and write 9x cubed minus 16x to the 4th cannot equal 0. So how do we start solving a problem like this? Well, we would take a look at what we have here. Always look for a GCF, which in this case, I could take out an x cubed from both of these. Leave me with 9 minus 16x. Yep, 9 minus 16x. Okay, so x cubed cannot be equal to 0. If I take the cube root of 0, x cannot be 0. Okay, and then I have 9 minus 16x cannot be 0. And then let's subtract 9. Negative 16x equals negative 9. Divide by negative 16. And x cannot be 9 over 16. So I have 2 spots where my domain would have issues, right? Because if I plugged in 0, I get 0 in my denominator. And if I plugged in 9/16, I would also get 0 in my denominator. So those are 2 spots that my domain can't be. But everything else is fair game. So everything else is fair game except for 0 and 9/16. So that would mean it starts at negative infinity, which of course I can't include, non-inclusive, up to 0. And again, I can't include 0 because if I plugged in 0, I would have an issue. Okay. Then it picks up back at 0, and it can go to 9 over 16. Now, a lot of students forget this interval, but think about it, right? Because in between 0 and 9/16, sure, that's not a very big number, but what about all that little stuff in between? That's fair game. So we can still use those numbers. And then we pick it back up, and notice how it's non-inclusive from 9/16 to positive infinity. So a lot of students will say, well, wait, you wrote 9/16. I thought we could include that. That's why the parentheses are so important. If my interval notation is in parentheses, that tells the person reading the domain, I can stop at 9/16, but don't include 9/16. Same with 0. Same with obviously positive, negative infinity. All right, so that's how you would do a question like number 11. And sure, we'll throw in one more here for this worksheet. Let's go ahead and do something like number 12. Okay, so it says f of x equals 5x over negative 18x squared plus 98. All right, so it's a rational function. I can't have 0 in my denominator, so I'm just going to say negative 18x squared plus 98 cannot be 0. So negative 18 and 98, I believe, if I'm doing my math correctly, I can pull out a number from both of those. I'm trying to think, does 9 go in there? Not quite sure, but they're both even, so I'll just pull out a 2 to start. I'll pull out a negative 2 to start. So that's going to give me 9x squared minus, and I believe that would be 49. Well, I'm glad I just pulled out negative 2 there, because negative 2, if I pull it out, it gives me 9x squared minus 49. And look, 9x squared perfect square, 49 perfect square, and it is the difference. Look at that. So I can just write 3x minus 7, 3x plus 7 equals 0. Again, that's the difference of two squares. You got to recognize that, got to be sharp at that. So if I set each part equal to 0, the negative 2 doesn't mean anything. X would be 7/3 and negative 7/3. And remember, that's where x cannot be. So those are the two values that x cannot be. It can't be 7/3 or negative 7/3. So for my intervals, again, it can be anything but those two. So that means I can go from negative infinity to negative 7/3, non-inclusive. Then go from negative 7/3 to positive 7/3. And then from 7/3 to positive infinity. So 3 different intervals there. All right, so that is how you write the domain with rational functions. Again, that number 10 was really good because it included not only rational domain issues, but with radical domains. Yeah, so that's how you find the domain with rational functions.